In lesson 3.3, we're looking at relative and absolute extrema on intervals. So we're going to use derivatives to find local, relative, and global or absolute extrema. We'll use both open interval and closed interval methods for finding extrema, and we'll talk about the candidates test. And then finally, we'll use and apply the EVT, the extreme value theorem, on intervals. So first, let's take a look at what we mean by absolute maxima and minima. So here we have part of a function that has been sketched for us over an interval from -1 to +4. And we can see that I do have an absolute maximum located at this endpoint here. So that's going to be located at the point 4, 5. And so the absolute maximum is the y value. It is 5. And this is an endpoint. Now we also have an absolute minimum, 1, that's located at the point 2, 1. Again, the y value is the minimum, and that is a value that is on the interval. Let's look at this example here. Another function sketched on the interval from -1 to +4 inclusive, and absolute maximum. So the absolute maximum should be this point 2, 5, but as you can see, that point does not exist for our function, and so the absolute maximum does not exist. Now it is true that I have values on either side of that. However, those would not be absolute maxima as they are the same height. Absolute minimum is going to be -1, and that is going to be located at the point -1, -1. And again, that is an end point. And this next function on the interval from a to b, we see that this function has a hole at a, which should be its lowest value, but does not exist. So this function does not have an absolute minimum, and it is also an unbounded function approaching positive infinity. It therefore does not have an absolute maximum. In this function, we do have an absolute maximum of 2 that is located at the point 3, 2, and that point is located on the interval. And then as far as absolute minima go, they do not exist because the lowest point is a hole.